Hi and welcome to tutorial 5 of the Steel Detailer. In this tutorial we're going to show you how to create a connection to be used within the Steel Detailer and then have it uploaded into a library. Okay, so for the first thing that we need to do is create a layout area for us to work. So if you open up Explorer and on your desktop create a new folder. I'm going to create a new folder here. Okay, and the new folder, I'm going to call it Connections. I prefer to use capitals just so that I can isolate the folder. And in the Connections area there is a certain naming convention associated to creating connections. The first 4 digits is the project number, and then the next one is the sequential number. Okay. You could create subfolders in here. So for instance, if I wanted to, I could create a folder and call it Base Plates Connections. And I just put my connection in there. Okay, and inside that folder is where I'm going to put my connection assembly. I need to copy the name of the folder, right? And I'm going to go over to TSD and SolidWorks, and I'm going to create a new assembly by either going File or clicking New, and then opening up an assembly. And I'm just going to use the default assemblies that come with SolidWorks as defaults. Now we're not putting anything in this at the moment, but what we need to do is save it into the folder location where we created the connections on the desktop. So I'm going to click Desktop, right, and I'm going to go to my Connections folder which I created over here, and in my Base Plates folder I have my connection, and I'm going to copy and I'm going to paste what I've copied over the top of the assembly to create the assembly name. So the assembly name must exist inside the folder and they with the same name. Okay, so we've now created a connection. Now connections themselves are pretty simple in their own form. Now there are 2 ways of creating connections. You can create connections outside of TSD or you can create connections within TSD. The first we're going to show you is how we create a connection outside of TSD. Now outside of TSD means that we cannot use TSD functionality. It means we cannot insert plates into connections. That means that we need to create all the items off to the side. So the first thing for a connection, and we're going to create a base plate connection, is obviously the base plate. So we need to create the base plate. We created a base plate before, and then go back to the desktop I should say, where we stored the base plate from before. And if we go into the base plate area under plates, we can actually grab the base plate out of there, right, by copying it, Control C, and then pasting it into the connections area to which we have established the base plate connection. So we need to go back down to our desktop, which is going to be this one, and select the connections folder, go into the base plate connection and paste our connection in there. You'll also notice that I've used the same convention for the naming of the plate as well as the assembly, which is crucial. Okay, that has to actually match. But now we've got this base plate, we can actually insert the base plate into our project so that we start with our connection with the base plate, and you can swap them around as need be. You'll also notice the P is important, which recognizes the word plate. It doesn't recognize the word plate. It uses the letter P to tell us that it is actually a plate model. That's a TSD naming convention. P is for plates, M is for members, D is for dummy members, which we're going to add in next, and V is for vendor item. Okay, so now we've got ourselves a plate inside of our assembly. We need to create a dummy component. So a dummy component is usually used to drive things. So let's just add one, and I'll show you how it functions the way it does. So a dummy component, we're just going to add a mass to it, but we don't really need to because it's just dummy and it doesn't get included in the bill of materials. Okay, I've just labeled it as plain carbon steel. Now if you've set your templates up already, you could select for your new plate plain carbon steel if you've already created one, so that you don't have to go and populate this again. So for a column, we need to draw ourselves a column dummy member stub. So I've just picked the front plane and I've picked the origin, and you'll notice that I've drawn a sketch and the orientation of the sketch is from the origin up vertically. And what I'm also going to do is I'm going to give this thing a length, and I'm going to save the sketch, rotate around so that the sketch is in 3D view. Okay, and at this point I can save it, and what I want to do is I want to match the previous one, but now because it's a dummy I want to change the P to a D. Okay, the sketch 1 that has come out needs to be renamed as member sketch. Now the reason that I've used the word or the descriptive word member sketch, in everything that you do in TSD, everything that has a member sketch, right, is snapped on to something via an in-contextual link. Now I'm going to show you what happens with this. The next thing that we need to do is put a Weldment on it, right? So we're going to go to our Weldments library, and inside my Weldments library, and you can get your Weldments library from us. If you haven't got one, come and see us before you continue, and you'll need to set one up so that you've got it. Okay, now if we select the BHP metric sections, this is just Australian. You can use whichever one you want from your country. I'm going to use a UB section, and I'm going to make it something around about the 310 UB size. I'm then going to select the line, and that puts me in a section. Okay, now it's a dummy section. Dummy sections I like to give a colour. It depends on you. I like to right mouse click, change the colour so that you can distinguish it when you put it into your library and then into your projects. Okay, so now that's the dummy member created, so we just save that. There's nothing else that needs to happen with dummy members. So now if we go to our window and go tile horizontal, you'll see we've got a dummy member. We're going to put it into our assembly. If you hold your mouse down by dragging it and dropping it in, right, that will allow you to add it to the project. Whoops, I've grabbed the bar. Let's do that again. Grab it and drag it down. Just be careful if you've got the freeze bar turned on. You can end up freezing things. Okay, so now we've added the dummy member and we've got our plate in place. Now the dummy member by default, when you drag it like that, goes to the origin. So if I click on the origin, you can see that the origin is now out there. By default, it used to go to the origin, but it's not in this case. Our plate is also not in the origin, so we need to move these over so that they're all fixed at the origin, because we're going to insert our connection by the origin. So I'm just adding a mate that is locking it down by axes. So origin, origin, and then mate. So now we have our dummy sketch in place with our plate. Now for all dummy sketches, because of the naming convention, we actually have to exclude them from the bill of materials. That way they're not included and the mass isn't included. So it means that when we do our mass, by going into our mass properties, if you haven't got this toolbar set up, it's just a simple right mouse click and go into tools and turn on tools, which is this one here. Make sure you mouse click up the top on the toolbar where it's empty. Okay, and now once you've turned that on, you can do a mass. Now what you want to do is, if this is ticked by default, you want to turn that off. Right? In any TSD project, you have to ensure that this is unticked, because we do not want to include dummy components or members that are excluded from the bill of materials so that they come up in the mass. Okay. Now you'll also notice the units haven't been set in this one. I'm going to set the units, okay, right now. So in my mass, I want to add my mass to my custom properties. So if I go File, Properties, under my custom properties, I'm going to put in weight. Now if you don't get a pull down here, it's just weight. And you type it in, and then you pick the weight, which is the mass. You'll notice that because my units aren't set, it's not giving me the mass I need. I need to set the mass. Down the bottom right hand corner in 13, we have this property which allows us to take us straight to the units. Now I'm going to make a custom one. Now this all can be set up within your templates. If you haven't done this, I suggest you set up a template that allows you to get the correct mass and length. Inches is definitely something that we need to change over and make that millimeters. So we've got millimeters, kilograms, and we've got meters. Okay, and we just save that so that that template's right. Now, so if I go back over into my file, it's very quick if you click on the wrong thing with this mouse. File, and then we go back to the custom properties. You'll notice now I've got a 28.61 mass, which is just this plate. If I open that plate up and I look at the mass, it's not set up properly either, so we need to set up its units as well so that it gives us the correct units. Now, templates are so important. You want to make sure your templates are set up right. So down into here, we click on that and we change it so that it's a custom, and we go kilograms per meters cubed and change that one to millimeters. Click OK. And in the plate we check the mass, and it's 9.51 kilograms. So after excluding the dummy component from the bill of materials, it will automatically be hidden when we go through a lock process. So if we just hide that, we can now get the mass, which means that the mass is 9.51 kilograms, which is the same mass as the plate when we open the plate. So we can get the mass for that, and it's 9.51 kilos. Okay, so a dummy component is just used for spatial constraints, and that is it. When you use TSD functionality, it will turn that off. Now, you'll also notice that the plate itself is pretty much useless at the moment. We want it so that it matches the member. So if the member changes, the plate will move with it as well. So what we can do is we can link the plate incontextually to the member. So the member itself will always remain where it is. So if we go into the actual plate itself, now I like to reorientate before we move and put the dummy member at the top and put it in a folder. So dummy part is what we call it, and in here we call it plates. So we add a new folder and we call it plates. Okay, so dummy member and plates. When we expand the plate out, we've got a whole sketch. We can actually edit the boss, which is the shape of the plate, which is what we're going to do now. And if we orientate the view so that the view is looking perpendicular, we can pull the plate out to wherever we wish to use. And in this case, if you pull it down so that it's just past the edge, some companies, depending on their structural design, will allow you to use a 6mm gap so that you can fully weld that plate. Now also too, I'm going to drive this 250, but the 250 itself I'm going to leave as a manual process because in most instances the plate itself is just only driven by the depth. When you change the flange size of the section, it's usually a manual process, but you could create configurations. Alright, so we save the sketch. So it means now that if we change that section size by clicking on it and going edit feature, by right mouse clicking edit feature, if I go to a larger section, alright, hit my tick, exit in context and then rebuild, the plate automatically updates. Now this functionality is definitely something that makes it a lot easier for us, so that when it comes to making the plates at the end of the day, all we're doing is just changing dimensions and it automatically updates. Now to do a rebuild, it's a control Q, okay, and then a control save just to save it. Okay, so now with the plate we have a drawing. Make sure that that drawing is right. We just do some general small updates to the drawing template, and we also have an issue where the plate itself is extruding, where the beam itself is extruding through the plate. So what we need to do is trim that plate. There is a TSD functionality that allows you to do that. Trim part weldment, okay, and trim part weldments only occur at assembly levels, but because we're doing this outside of TSD, we cannot trim that back. So we're going to trim it back through the manual process to which TSD would normally do automated. So if we edit this part in context, select the top face and then put a plane on it by selecting just S on the keyboard, which will bring up a shortcut menu. Click on the plane and add a plane. Now what we need to do is make it so that it's coincident and then hit the tick. Right, now we have something that we can actually trim this part back to. Right, so if we save it, we can do that. Now you ask me, why can you not trim back using SolidWorks functionality back to the face? Well, if you do a rebuild on a trim with SolidWorks, it will not update at a high level. But if you do a plane and then trim the member back with the plane inside of it and you do a rebuild, it will actually trim, and I'll show you that so that you can see it. So I'm going to use weldments and then I'm going to go trim. Click the member, click the face to which I'm going to, you have to click the box, click the face or the plane. In this case we're using a plane, so you want to select that plane. Make sure you've got face and plane ticked, and then click the plane. Okay, and we want to discard this piece and keep that piece and hit the tick. Okay, so now that's trimmed that member back. Now that plane is incontextually linked to the top of that plate. Now you'll see the trim. Now if I change the depth or the thickness of this plate, and I'm just going to blow it right out of proportion so that you can see that it will update automatically on a rebuild. Okay, now if I did that with just a trim to a face and did a rebuild, that would not work. Okay, now I'll put this back to where it was. Control Q, and there is my basic connection. Now in my connection I might want to put some bolts in. Now fasteners. Inside TSD there is a fasteners folder. Alright, if you go to the TSD folder and open it up, which is C, the steel detailer and fasteners, there is an M20 holding down bolt that you can drag and drop straight in. Okay, so there's the holding down bolt. Now the holding down bolt itself, you could have dropped it and dragged it and used the SmartMates and positioned it within that circular center. Now I'm going to just use a mating process. I've hit my control key, hit the cylinder, hit the bolt, and now I've locked it into place. Now what I also want to do is inside this there are planes that are set up, so I can set my distances for my bolt and how it is positioned. Now with bolts, they can have a cog. You can set them up so that they don't have a cog. It's up to you on how you want them to work. All I'm doing is just basically positioning this in such a way that it's positioned and locked. Now you'll notice some funny things going on here. Just hit parallel and that'll put it back to where it was. Do a rebuild and everything's back to normal again. Now I don't want to save that bolt. Now if I hit Control S, it will try and save the bolt. What we need to do now is click on the bolt and make it virtual. So right mouse click, make virtual. Okay, now this breaks the link and we're going to put it outside. So now what this means is the actual bolt itself is contained within the assembly and there is no external file. That makes it virtual. Now what you've also got to do is you've got to label it so that it becomes the M20 bolt in the naming process. Okay, so there's my bolt, it's positioned. What I want to do now is add another 3. To do that, I just right mouse click on the bolt itself and I go copy with mates, and in here the concentric mate is the one that I want to be available. The other 2 I'm going to repeat the processes. Okay, so by copying I select the cylinder, by ticking those 2 on I've locked those 2, and if I select the cylinder it creates a new bolt. Hit your tick, new bolt's been added, hit your tick, new bolt's been added, and then hit your tick and a new bolt has been added. Now we just need to shuffle 2 of them around. So if you right mouse click this one, okay, and go into, sorry, don't right mouse, just click this one, go into it, go to the mates, click on the mate that's locking it in position, right mouse click and go flip mate, and that'll turn it around the other way. You can do that with the other one as well. Click it and it'll highlight it in the tree. Go to the mates folder, right mouse click the parallel face and go flip mate, and that turns it around. Okay, now there's no nuts or anything on those bolts. You can go and model whatever you like as far as you're concerned on how you want to achieve that. Now this is just a base plate that has no grout. If you was going to add a grout piece underneath this so that you would lift the plate up off the ground or off the origin by putting a bit of a space under there to grout it, you would actually position your plate in such a way that it was offset. You don't need to show grout, but you can. And if you do bring a grout part in, make sure that it is, it looks like, while I'm at it, so that I can show you, it looks like my trim that I've added has got a gap. And make sure you turn that off, because you don't want a weld gap. Okay, now back to where I was. Now if you want to add a grout part to that, you make the grout part a dummy part and exclude it from the bill of materials. I'm not going to show you that, but you can. Now to position this so that it's not on origin, and I'm going to give myself enough room for grout because grouting is stock standard in a lot of scenarios, I'm going to use a different mating process to position that. So if I click the origin and delete it, I'm going to now use the top, which is the top of the plate and the top of of the assembly, and I'm going to click my S, which is my shortcut key, and hit my clip. I'm going to put a distance between the two of them, and let's just say I'm going to use, say, 30 grout. Now you'll notice that it's moved down. Right, I want to flip the movement so that it's up above. Now that gives me 30 mils in there to move things around. But you'll also notice that this is not fully defined. Down in here it's not fully defined, it says it's underdefined, so I need to continue to mate my plate in place. So the front plane and the front plane, I lock those two together coincidentally, and the right plane and the right plane together coincidentally. That locks the plate in place, and now we've got ourselves down here a fully defined model. So if I ever need to move my plate, I can just go into here and grab my distance and double click on it, and I can move my plate to whichever position I want in grout. Okay, back to 30. And that exactly is how you would set it up so that your connection would go in and insert at that point. Okay, so now we've got ourselves a basic connection. The items that we have added, being fasteners, all now need to be excluded from the bill of materials. I know that excluding from bill of materials will exclude it from the bill of materials and it will not show up. And the reason for that is because that's how TSD handles it in the database. It's a filtering mechanism. Now we're going to add the bolts to a folder, and we're going to call it fasteners. Okay. So now we've got ourselves a connection that we can use. Let's now upload the connection to the connection library. In the connection library, if you go to upload connection, which is at the very top, and we want to use the default that we've got, which is the current open connection, and we want to select which filter to find our connections, and in this case it's actually a base, so the default is base. And if we hit the tick, that now is appending our connection to the connection library. Okay, so now we've got our connection off to the side. Let's go back to the project and the area that we created in tutorials 1 and 2. Okay, that's those two, and go log in. By default, TSD automatically goes to the last logged in model. Okay, so if you remember, in the plate creation tutorial, which is the previous tutorial, we created a plate and we placed it in here. If we go in and open up that assembly at that level, we can remove the plate. If we use the TSD parts delete plate and then click the plate, we can delete the old plate that was in there, and you'll also notice that when we open up the folder, the plate has disappeared as a file. When we use TSD delete functions, it removes the file as well as the information in the database that holds it there. Okay, so now we have our column with no connection. So what we want to do now is back into the area assembly, because you can only insert connections at the area assembly. We need to be back in there. Now, for a connection to be inserted, we need two members. I know this may be confusing, but because we've only got one member in there, we need to put one in there to tell it that there is another member to connect to. So I'm just holding my control key down, and I've selected the column and I've dragged another column, which creates a second instance of the same column. Okay. Now, if I go into my TSD connections and I go base plate connection, the connection to which we uploaded will be the last one on the list, and there it is there. Now, remembering that the snapshot that gets created is based on your current position of your connection. Now, if your connection is zoomed right up, that'll be the snapshot. So I'm going to select that connection, which is the one we just created, and I'm going to select the member to which I'm going to insert it, which is the very first one, and I'm going to use the origin point, which is the beginning of the sketch of the member sketch associated to that member. I'm now selecting the section, and I'm selecting the opposite section which is required in the process. Later we'll remove it, but for this instance we'll leave it. Okay, so now you'll notice that if you go into that subassembly, a new connection has been added. And funnily enough, the actual section size has matched the default section size, so we've ended up with two of the same section. Okay, now you'll notice that the new connections come in, but we have a member that has not been trimmed. So if we go up, so now what we want to do is we want to trim this base plate. So if you go to TSD Utilities, trim the base plate, you click the member weldment that we're going to, member section that we're going to trim, and then we select the top of the plate, and then we hit the tick, and that'll trim that back. Okay, so now the plate itself is driving the main section. That's how a connection is added in TSD. And now we have full functionality for us to be able to modify that connection based on the section size. One other thing you should notice is that when we insert a connection into a member, it creates the connection name and file sequence and positions our connection based on a sketch point. So when we insert, the actual sketch point itself becomes the point of in-contextual reference in the driving sketch in the area above. In this instance, that has not occurred. It has created the driving sketch without in-contextual links because there are none. So you'll see that very first description of it is CN01, which is the actual connection in sequence, and then the BP08 is the actual BP type. In that case, BP being base plate under the BP code for creating connections. Okay, and you'll also notice the connection follows the same naming sequence. So you've got CN01 BP08 and the sketch is CN01 BP08. So you know that these two are linked by file name and position. You'll notice that the mates that have gone in are associated and linked to that sketch point. So if I was to unlink that sketch point, that connection would go with it. Okay, now that is a basic process that's associated to the way TSD operates. If I was to add another connection to this member, it would take the next sequential number and it would attach the actual connection type to it again, and you would end up with another connection assembly below it named similar, except that it will be CN02 being the second connection in sequence. Just something that you should note.